everyone, in this video we're going to go through the theory from chapter 1 for your methods. So just looking at some, I guess, the real fundamentals of things like notation and functions and relations and stuff like that. This very first page, I'm not going to go through every single one, but you do need to understand what the symbols mean and give an example. So I will provide you with how to fill this out, but I won't do it in a video because it would be very long and not as exciting as my other videos. So just make sure you write, what I might do is just highlight the ones that you definitely need to know. They're all important, but just understanding, what a set is, what this E is, so it means element of, so you might see that turning up. Subset, we also will use intersection, and we have a union, there it is, and then the union symbol as well. We use R a lot in function notation, so that just means real numbers. You can just write capital R, you don't have to write it a fancy R like that. But also knowing N is a natural number, Z integers, and Q is used not as frequently, but it's there just in case you do encounter it. All right, in terms of interval notation, so with your domain and range, you can write it using this notation here with your brackets, or you could use your inequality signs. So it's extremely important that you remember that your lowest number always goes first. So I always see every year that I teach methods that students put them around the wrong way. So you do need to put your lower number first and then the higher number second, and have the correct brackets. So you would have done this in year 11, so I'm not going to explain it here, but it's extremely important because if you get it wrong, whoever is assessing your work is not going to be kind to you and say, oh, they were on the right track. It's either right or wrong. So just making sure you understand that a curved bracket means that it is not included, and a square bracket means that it is included. All right, so when we do some questions in this video, hopefully that'll make more sense to you. And then just down the bottom, R positive just means any real value greater than 0, so it does not include 0. And R negative is any negative real value, but doesn't include 0. And R is any real value including 0, so if you didn't want to include 0, you had to say excluding 0, like we've done there. All right, so let's move on to 1b. So identifying and describing relations and functions. All right, so the main difference between a relation and a function is a relation is a set of ordered pairs. All right, so it may be a set of coordinates. And a function, and I'm just going to read the definition here, is a relation that no two ordered pairs in the relation have the same first coordinate. That is, for each x value, there is only one corresponding y value. So we'll get back to the domain and range in a second. So to test whether it is a function, we just do the vertical line test. So I'm going to show you 3 examples. All right, so I'm just going to draw 3 quick axes and 3 graphs. So we'll do a linear, we'll do a parabola, and we'll do a circle. All right, so the vertical line test just means, and I might do the vertical line in green. All right, so I need to be able to draw a vertical line anywhere on that graph, and if I can do that, then it's a function. So just means we've got one x value to each y value. Now, so this is a function. Your parabola is also a function. And we've got a circle. So if I was to do my vertical line test, it's going to cross it twice. So if it crosses it more than once, it's not a function. All right, so to make So sorry, start again. Sometimes when you're dealing with functions, you need to restrict your domain. So that's what we're looking at here. If I just go back up to the definition of domain and range. So your domain is just your set of x coordinates. All right, so that are true. So we look at implied domain usually, but you can actually also have a restricted domain, and I'll talk about the difference between them in a second. And the range is your set of y coordinates. So let me just show you some examples, getting up my little axes. Let's have a look at 3. So if we just had a parabola, all right, and let's say that was just, what could that be? That could be x squared minus 5. Your implied domain is x is an element of any real value. All right, I haven't restricted it, and with your parabola, your x values go on forever. So I could write it like that, x is an element of R. I could also say it goes from negative infinity to infinity, and when we're dealing with infinity, we have to always use curved brackets. I could also say x is going from negative infinity to infinity. The last one, if you're using it, just make sure your inequality signs are around the right way. So I kind of think if you like the crocodile analogy, your crocodile is swimming across your page. All right, so keep them around the right way. Now, if I'm restricting it, so let's say I'm going same parabola, and I'm restricting it from there to there. So let's say this is -1, and that's 1. So I've got the same function, but this time I'm going from, and I've got closed circles here. Actually, I might do one as an open circle. All right, so when it's included, we have, when it's a closed circle, it's included. So x is greater than or equal to -1, and an open circle means that it's not included. So we say that it's less than 1. We can also say, use our brackets. So we use a square bracket at -1 and an open bracket at 1. All right, now moving on to the next one. If we're doing an inverse, it does have to be a 1-to-1 function, so maybe I would restrict it there, and it can keep going forever. That's fine. So for this one, x is including 0, so it's from there, and it's going on forever to infinity. If I was doing, I could say x is an element of any real positive value, including 0 and 0. Or I could use my square brackets for 0 because it's included to negative infinity. Now, my preference is always the brackets. I probably shouldn't do that because it's a bit hard to see now. All right, but you can use any notation. All right, so let's have a look at a few questions. So which of the following relations are functions, and state the domain and range for each of them? So for the first one, we've got x and 4. So basically, if I was to graph that, it is a point, but x can be any value. So basically our y is 4, and it can be any value on that line. So doing my vertical line test to test whether it's a function. All right, so we go down, it is a function. All right, your domain, so it's given to us here. So x is any real value. That's your domain. And your range is just the y values. So it's just 4. All right, so it's the only value. squiggly brackets. All right, moving on to the next one. So we've got 2y. And it says y is an element of z. Now, once you've filled in your set notation sheet, let me just go back. So going back up here, so we had z, where are you? Up here. All right, so z is an integer. So an integer is just a whole number. So going back down here. So because it's a whole number, we can't, it's a little bit different to r. So r is any value, whereas z's just an integer. So if I'm going at x equals 2, should be here, we're just going to have dots. I probably shouldn't do dots because then, anyway, so they're dots because y can only be integer values. So we could have, say this was 2, 3, this is 2, 2, 2, 1, etc. It's different to the previous one because x could be any real value, whereas this one, y, is only the integers. So it couldn't be like a half because 1/2 is not an integer. It's not a whole number. All right, so does it pass the vertical line test? Clearly not, because it is itself a vertical line, so it is just a relation. So our domain is just 2, so x is an element of just 2. And we've got our range there, so y is an element of integers, sorry. All right, moving on to C. So this one here, we've got a straight line graph. So it goes through 4 and it's got a gradient of -2. So is it going to be, right, it's going to be 2 here. So it goes down like that. All right, so crossing that graph using our vertical line test, we can see it's only going to cross it once. So it is a function. And your domain, so x can be any real value, and so can y. All right, and then lastly, D, we've got an inequality sign. So all that means is if I just quickly draw my graph, let's say it goes like, oops, not there, this side. All right, go something like that. That just means y has to be greater than this line. So it means all these values here. All right, so we don't have an equal sign there, so it's not treated the same as it is in part C because we've got all those values. So it is not a function or a relation. And your domain is any real value and your range is any real value as well. All right, so slightly different because we've got that inequality sign there. All right, so let's have a look at question 2. So consider the function, so we've got f of x is equal to 2x minus 3. So the image of 3 just means, well, we're going to let x equal 3. So we're just substituting that into our equation. So 2 times 3 minus 3, I'll let you finish that off. So the pre-image now just means we're letting basically y equal 11, which is y is the same as f of x, so f of x is equal to 11. So 2x minus 3 is equal to 11. So just a different wording, I guess. So image, we're letting x equal 3. The pre-image, we're letting f of x equal 11. All right, so this time we've got f of x is equal to 4x. So that just means we're multiplying x. Sorry, we're not multiplying x by 4. We're letting f of x equal 4x. So our f of x is 2x minus 3, and we're letting it equal 4x. So you might be used to seeing them with just a number as opposed to another expression. All right, and then we've got f of x is greater than x, so f of x being 2x minus 3 has to be greater than x. and you can just solve for that. All right. Let's move on. I'd like you to finish those questions. I'm just conscious of the video taking forever if I do every little thing. All right, g of x equals h of x. So we just write g of x, 6x plus 7 is equal to 3x minus 2. All right, just go on and solve for x. This one we've got a greater than sign, so 6x plus 7 is greater than 3x minus 2. So again, you just go through and solve for x. And then we've got hx equals 0, so h being 3x minus 2, just let that equal 0 and solve for x. All right, in question 4, we're going to rewrite it using this notation. So you often will see this in your textbook. All right, so this just means we've got the function y equals 2x plus 3. So if we're writing it using function notation, we just say f being our function, and r is, remember, any real value. So any real value of any real value of x is mapped to any real value of y. So when you see this, you may not have r here, but that is your domain. All right, so that when you're given this notation, that's your domain, and I might just write that there. All right, and then f of x, and then we just write our function, 2x plus 3. All right, for the next one, again, we've got, so for the previous one, we had an implied domain. This one here, it's given us our domain. So r again. And then f of x is equal to x squared minus 9. So in our function notation, we're given the domain, but not the range, because the range is dependent on the domain. So for this one here, we know the domain is any real value, but if you think about this, it's a parabola, and it's gone down 9. So it's gone down, and it'll be here. So your range goes from -9 to infinity. All right, so always think about, you've always got to kind of think about what the range is, and the domain as well. But if you've got function notation, it's given it to you in most cases. All right, for this one, we've got a restricted domain. So we're just going to write that in. So x is between 0 and 2 and including 0 and 2. So we make sure we use our square brackets. All right, and then we've got f of x is equal to 5x minus 3. Now, when we do a question like this, your domain has been restricted, so you then would have to work out what your range is. So it's a straight line, 5x minus 3, all right, something like that. Let's say it's restricted here at 0 and 2 up here. So we just need to find those corresponding y coordinates to get our domain. So here, x is 0. When I substitute 0 in, I get -3. And for this one, when I substitute 2 in, I get 5 times 2 is 10, so -3 is 7. So my range, and we're including both those values, is going from -3, whoops, that is a very bad 7, to 7. They do get a linear graph is easy to do the range for. It's when you do like a parabola or another type of graph that you need to also consider the turning point. So we'll do questions like that later on. All right, so sketch the graph of each of the following, stating the range of each one. So here we've got a linear. They're all linears actually. All right, so those three, doing it exactly the same as what I did in question 4 part C. So drawing your graph and then stating what the range is. I'm going to give you the answers, but I want you to work it out for yourself. All right, so our range is from 3 to infinity. Just make sure you can get these answers. I don't want you to just write them down. So if you're unsure about how to do this, make sure you get some help with it. All right, I'm just don't want to take forever in this video, but you'll need to do the actual sketching of the graphs. So you should be able to do them. They're all straight line graphs, and make sure you're restricting them as well. So you can do it on your calculator to check, and you can check on Desmos as well. All right, going over the page, we've just got a few more, so one more. So we've got another linear graph. So your range is going from -5 to 14. Just make sure that's right. I think it's right. I'm copying down answers from what I've done years ago. All right, so for question 6, this one you should be able to do. You've done this sort of notation before. So this -2, we're just substituting in for x. Here we're substituting in 2. Here we're substituting in -a. Now just remember, when you're substituting in a negative value, it's probably a good idea to put it in brackets. That's because when you square a negative, it becomes a positive. All right, so just be careful of that. Same applies here when you substitute in -a. Part D is a sum function, so we're actually doing f of a. So you have a squared plus a, that's f of a, and then we've got f of -a. So we're going to add f of -a, so -a squared plus -a. So we have a squared plus a squared minus a. So our a's cancel out and we're just left with 2a squared. All right, so just using the substitution. Then we've got the difference. So you do the same thing as before, but instead you're going to be subtracting f of a squared in terms of a. So that's just substituting in a squared. So we're just going back up here. What do we have? X squared plus x. So a squared plus, sorry, what am I doing? So that all had to be squared plus a squared. All right, because remember it was x squared plus x, and in this one x is equal to a squared. All right, so your power to a power, we multiply them, so it's going to be 4 plus a squared, and there you go. All right, find the values of x for which the given functions have the given value. So this time we just do it the other way around. So we're given the value of f of x. Remember, it's the same as y. So we can say 5x minus 4 is equal to 2, and solve for x. And then, what have I got here? F of x equals 1 over x, and f of x equals 5. So I think 2 separate questions here. So, oh no. Sorry, they're simultaneous equations. What am I doing? So f of x minus 4 when f of x is equal to 2. All right, so 1 over x is equal to 5. All right, so solving for that. And again, 1 over x squared is equal to 9. X plus 1 over x is equal to 2. And then we've got a parabola. And we're letting that equal 0. So we've been given our function, and then we've given what f of x is also equal to. So we're just letting f of x equal f of x. All right, now I think we're going on to 1c here. So I might just stop here and do 1c and 1d in a separate video. All right, bye guys.